Hello again. We are starting Chapter 8 now, and this is Section 8.1. It's called Right Triangle Trigonometry. And a lot of this is review from Geometry or Integrated 2, whichever you had. We are going to learn how to evaluate trigonometric functions using of acute angles that are in a right triangle. We're going to learn how to find unknown side lengths and angle measures of the right triangles, and how to use trigonometric functions to solve real-life problems. So those are the goals for the day, or things that we're going to learn in this unit, or this section. All right, so Sohcahtoa, most of you are familiar with, or that's the abbreviation for sine equals opposite over hypotenuse. So SOH was the SO for sine theta equals opposite over hypotenuse. Ka, which is CAH, and then TOA, TOA, for tangent theta equals opposite over adjacent. Now, I'm not sure if you're familiar with the theta, but theta is just our variable, and that is, it's called theta, Theta, is basically the angle. And in a lot of textbooks they use that symbol, which is another Greek letter called theta, to write to represent the measurement of the angle. But in the past, maybe you just saw it as a variable like x or y, but it's kind of like this, like kind of like a cursive O. But that's how you write theta. There are actually 6 trigonometric functions, though. So sine, cosine, and tangent you are familiar with, or you should be familiar with, as sine equals opposite over hypotenuse. But cosine, secant, and cotangent are the other 3 trigonometric functions. So there's actually 6 of them, and they are inverses of each other. So cosecant is the inverse of sine. Secant is the inverse of cosine. And cotangent is the inverse of tangent. So when I was first trying to remember these, what helped me remember, number one, is cotangent always went with tangent. But as far as the other 2, what I tried to remember is there has to be one of each. So if sine, so the inverse of sine cannot start with S, it had to start with C. And the inverse of cosine had to start with S, not C. So I don't know if that'll help you remember, but that's one of the things that helped me remember them. Another thing that I want to mention is the formulas here that we use for cosecant. If you notice, it's flipped. So instead of opposite over hypotenuse, you have hypotenuse over the opposite. You can also, in your calculator, if you want to, so on your calculator, you don't have a cosecant, secant, or cotangent button on your calculator. So what you need to do in order to calculate cosecant, secant, and cotangent on your calculator, you're going to take 1 divided by sine. So 1 divided by sine theta is going to equal your cosecant theta. And then to find secant, you would take 1 divided by cosine theta, and that would equal your secant. And then you would take 1 divided by tangent theta, and that would equal your cotangent. But if you're given the numbers, just hypotenuse over opposite, hypotenuse over adjacent, or adjacent over opposite, which again are the reciprocals of these ratios over here. So these again are used to calculate on a calculator. But if we look at each of these ratios, we basically have the reciprocal of sine. And this ratio here is the reciprocal of cosine. and this ratio, cotangent, the ratio for cotangent is the reciprocal of tangent. Okay, so then I would like to take a look at our right triangle. Again, this is only for right triangles. So one of your angles has to be a right angle. And across from the right angle, you will always have your longest side, which is the hypotenuse. If your theta, your angle theta, is here, this is your angle is an acute angle, the side that is the leg that is next to it is called the adjacent. So adjacent meaning next to. The side that is across from that acute angle is called the opposite side. So the hypotenuse is always opposite of the right angle. Depending on which angle you're working with, if this is the angle you're working with, then this is the opposite and that is the adjacent leg. But if you were working with this angle up here, this would be the opposite and this would be the adjacent leg. So it depends on which angle you're working with, which leg is the opposite or the adjacent. Okay, so in example 1, what you're asked to do is evaluate the 6 trigonometric functions of angle theta. Evaluate the 6 trigonometric functions of angle theta. So theta is right there, and we're told what the legs are. So the side that's opposite, the leg that's opposite theta is 15. So 15 is going to be our opposite. The side that's next to theta is the adjacent, but we don't know the hypotenuse. So the hypotenuse we're going to have to figure out. So to figure out the hypotenuse, you're going to use your Pythagorean theorem. So Pythagorean theorem you should be familiar with is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse of the right triangle. So it doesn't really matter which one you plug in for a or b. I'll just put 8 in for a and 15 in for b, and that's going to equal our c squared. So if I take my 8 and square it, I get 64, plus my 15 squared gives me 225. That equals c squared. Add them together and you'll get 289 equals c squared. Then if you take the square root, you get c equals 17. So we only have positive square roots because it's a length. Normally, if we were solving a square root equation, we would have a positive and a negative answer. However, because it's the length of the side of the triangle, it has to be positive. So your hypotenuse now is equal to 17. So now that we have all of the 3 sides of our triangle, we can then plug them into our ratios. So again, sine, if you forgot, is opposite over hypotenuse. So my ratio for sine, my opposite is 15, my hypotenuse is 17. So 15 over 17. Well, cosecant is just the inverse or reciprocal of that. So it's going to be the hypotenuse on the top and the opposite on the bottom. So if I just flip this fraction, I would have 15 or 17 over 15. Your cosine is adjacent over hypotenuse. So that's what cosine equals. The adjacent side is 8, the hypotenuse is 17, so 8 over 17 is our ratio. Secant is the reciprocal of that, hypotenuse over adjacent. So the hypotenuse being 17, the adjacent being 8, so it's 17 over 8. If you are doing any of these problems and you have a fraction that can be reduced, then you want to reduce it, but it is okay to leave it improper. You just can't have any common factors in the numerator and denominator. Okay, your tangent is your last one. That one's your opposite over adjacent. Opposite is 8, adjacent is 15. Cotangent is the reciprocal of that, or adjacent over opposite. So 15 over 8. So that's one example of finding the 6 trigonometric functions of a right triangle. Moving on to example 2. In example 2, you're given a little bit different information. You're being told that in a right triangle, theta is an acute angle, just like what we had in the first example. But instead of giving you the sides, they're giving you one of the trigonometric functions, and they can give you any of the 6. And they want you to evaluate the other 5 trigonometric functions. So what I would recommend is that you actually draw a picture of a right triangle off to the side. And you can put your theta here, or you can put your theta here. I'm just going to put it down here. And the side opposite will be over here. The side, or the leg that's adjacent, would be here. And then, of course, the hypotenuse is across from the right angle. So here's my right angle, opposite. Now what they are telling you is your cosecant. So if we look at what the ratio is for cosecant, it's the inverse or the reciprocal of sine. So if sine is opposite over hypotenuse, again, it helps if you write these out, it helps you remember them, then cosecant is hypotenuse over opposite. So if you're given cosecant theta is 6 over 5, then you can basically use 6 to represent the hypotenuse and 5 to represent the length of the opposite leg. So going back now to our triangle, I can say the hypotenuse is going to equal 6. My opposite is going to equal 5. So I need to find my adjacent. Once again, we're going to use Pythagorean theorem, but since we are given the hypotenuse, I'm going to use the formula c squared equals a squared minus b squared. So I'm going to substitute 5 for a and 6 for c. So I'm going to subtract from the hypotenuse. Wait, no, that's not right. What am I thinking? Sorry about that. I'm going to take my hypotenuse squared minus my opposite squared, you can call it a squared, equals b squared. So the hypotenuse, if I take 6 squared minus the 5 squared, that's going to equal the adjacent squared, or I'm going to call it b. So 6 squared is 36 minus 25 will equal 11. So if 11 is equal to b squared, when I take the square root of that, you're going to leave it in radical form. You want your answers to be exact. So I'm going to say that b is equal to the square root of 11. So my adjacent side is equal to the square root of 11. And you want those answers to be exact. So yes, you will have some radicals, and you might be simplifying radicals, you might be rationalizing denominators with radicals, but those are all skills that you've already learned, so you'll be fine. Now let's go back and fill in the rest of these. Now that we have our 3 sides of our triangle, we can fill in the ratios. So we've already got this one. So my sine is the reciprocal of cosecant. So if I just flip that fraction, I'm going to get 5 over 6. Or if I look at my triangle, the opposite over the hypotenuse, 5 over 6. Now let's go to cosine. So cosine is adjacent over hypotenuse. So if I go to my triangle, the adjacent is the square root of 11, hypotenuse is 6. So my ratio is going to be square root of 11 over 6. Well, secant is the reciprocal or inverse of cosine. So I'm going to have to put the hypotenuse at the top and the adjacent on the bottom. So if I flip this fraction, I would have 6 at the top and the square root of 11 at the bottom. That square root of 11 at the bottom is a problem. We have to rationalize that denominator. So we're going to multiply, because it's just a square root, we're just going to multiply it by itself. Remember, you can only do that with a square root, not with a cubed root or a fourth root. Just square roots would you multiply by itself. So the simplified numerator would be 6 square root of 11 over 11. Because when you square a square root, you get just the number that's underneath. So that's our secant. So that one was a little bit tricky. Now let's move on to tangent. So tangent, our ratio is opposite over adjacent. So if we look at our triangle again, the opposite was 5. The adjacent is square root of 11, or yeah, opposite over adjacent, 5 over the square root of 11. So again, we're going to have to rationalize our denominator. Multiply by the square root of 11 over the square root of 11, which then will equal 5 square root of 11 over 11. And that's as much as we can simplify it. Now, when it comes to the cotangent is the reciprocal of your tangent, but rather than using the one that you rationalized, go back to the original, because if I flip that 5 over square root of 11, now my square root of 11 is at the top and the 5 is at the bottom. And that's okay to have a radical in the numerator. It's just not okay to have a radical in the denominator. But again, the ratio is adjacent over opposite for cotangent. All right, so there's your one example for finding the 6 trigonometric functions if you are given one of the 6 functions and you have to find the other 5. Okay, next we have example 3. Actually, before we get to example 3 though, there is this table here that I want to take a minute to talk about. When you were in Integrated 2 or Geometry, you had special right triangles. So the special right triangles were your 30, 60, 90 and your 45, 45, 90. And if you remember, the smallest side, or the side that's across from the 30-degree angle, the ratios of these sides was 1 to 2 to square root of 3. Where 45, 45, 90, these two would have a ratio of 1, and the hypotenuse was square root of 2. So if you were asked to find the sine of theta, this 1/2 comes from, well, sine of theta is opposite over hypotenuse. So the opposite of the 30-degree angle is 1, hypotenuse is 2. So that's where we get the 1/2 from. If you were trying to find the cosine of theta, and theta was 30 degrees again, so cosine would be the adjacent over the hypotenuse. So square root of 3 over 2. So that would be that ratio there. Your tangent is opposite over adjacent. So if we do the opposite, we would have 1 over the adjacent, which is square root of 3. So that 1 over square root of 3, when you rationalize the denominator, would be square root of 3 over 3. And then if we look at your inverses, 2 is the inverse or the reciprocal of 1/2. So these two are inverses of each other. These two are inverses of each other. And these two are inverses of each other. Okay, sorry about that. I wanted to flip my page in my notes. So sine theta, cosecant theta, if you look at these numbers, they're reciprocals of each other. This one here also, this was, if you were to put this over 1 and then flip it, it would be 1 over square root of 2. And when we rationalize the denominator, that would equal square root of 2 over 2. And same thing here. If you were to look at the picture, say we're taking sine of 60 degrees. Well, 60 degrees is here. Sine would be the opposite over the hypotenuse, which would be square root of 3 over 2. That's fine because the radical's in the numerator. But if I go to flip it, do the reciprocal, 2 over square root of 3, you cannot leave it with a radical in the denominator. So you would have to rationalize the denominator, and that's why this is 2 square root of 3 over 3. If we take just a little closer look at our cosine and our secant, again, you'll see those same reciprocals. And so this one originally was 2 over the square root of 3, which when we rationalize the denominator becomes 2 square root of 3 over 3. This one, if we put this over 1 and took the reciprocal over here, it would be 1 over the square root of 2, which when we rationalize would become square root of 2 over 2. Well, in the 45-degree angle, when you're doing tangent, so this is tangent, so if you're doing the tangent, taking the tangent of 45, it's going to be opposite over adjacent, or just 1 over 1. And if you take the reciprocal of that, it's still 1 over 1. So your tangent and your cotangent are the same, only for the 45, 45, 90. All right, so that's how this table is used. So in example 3, the idea is that you use the special triangles to find the missing side. So if you are given a 30-degree angle and you're trying to find the side that is adjacent or next to that 30-degree angle, but you're given the tangent or the hypotenuse, you have to think about, well, what sine ratio am I going to use if I want to find the adjacent and I'm given the hypotenuse? So the answer to that would be cosine. So the cosine of 30 degrees is equal to the adjacent, or x, over the hypotenuse, 16. So now we have to solve for x. To solve for x, you're going to multiply both sides of the equation by 16. So then when you multiply both sides of the equation by 16, that 16 cancels out. And in this step, you need to plug it in a calculator. Oh, wait. No, we don't. Okay, I just looked at my notes from last year. We know the ratio for cosine 30. All right, let me back up and erase this. Yeah, so you don't need a calculator for this. So cosine theta, if you look at, or cosine 30 degrees, is adjacent over hypotenuse. Oops, I'm looking up here. So in your special right triangle, 30 degrees is here. The adjacent would be square root of 3 over 2. So the ratio for cosine 30 is square root of 3 over 2. So you can replace cosine 30 degrees with square root of 3 over 2. So cosine 30 degrees equals square root of 3 over 2. So that would equal then x over 16. So that proportion should equal that proportion, or that ratio should equal this ratio. So then if we cross multiply, we can then solve. So the 16 times the square root, or 2 times x would be 2x equals 16 square root of 3. Then divide by 2. And we get x equals 8 square root of 3. And that is our answer, and we didn't need a calculator at all. Okay, so I have one more example over here with a 45-degree angle. Hopefully we can do this one correct the first time. So my 45-degree angle is here. You're given the opposite leg, and you're trying to find the hypotenuse. So which I kind of gave it away. Which trigonometric function uses opposite and hypotenuse? Sine. So we can write our equation as sine 45 degrees equals the opposite, which is 20, over the hypotenuse, which we're trying to find is x. Well, if you know your special right triangles, look back at your 45, 45. So if we take either one of these 45, the opposite ratio is 1 over the hypotenuse, which is square root of 2. So sine 45 is going to equal 1 over the square root of 2. And you don't have to necessarily worry about using the simplified radical. So you could use the square root of 2 over 2, or you could just use the 1 over square root of 2. So I would use the 1 over square root of 2, since that's not my final answer. So sine 45 degrees can be replaced with 1 over square root of 2. And that's going to then equal the 20 over x. And again, we can cross multiply. So 1 times x is just x, and square root of 2 times 20 is 20 square root of 2. So that kind of helped not having this in rationalized form, because when we multiplied that, it was a little bit easier. So 20 square root of 2 gives us our answer for x. All right, well, what if you have to use angles that are not 30, 60, 90 or 45, 45, 90? And what if you have to solve? So this is an important word here, solve triangle ABC. Again, you should have done this back in geometry or in integrated 2. But when your directions are to solve the triangle, this means find all the angles or the measurements of all angle measures and side measures. I could have just said find all measures of the angles and the sides, but that's basically what it means to solve a triangle. So we want to find the measurement of angle A, the measurement of angle B, and the measurement of angle C. Well, in the instructions, they gave you the measurement for angle A was 34 degrees. And if this is a right triangle, we could draw a picture that would help us out. So we have a right angle there. Well, angle C is always representing your 90 degree angle. So the measure of angle C has to be 90 degrees, because the side opposite of angle C is little c, which is our hypotenuse. Now, whichever one you want to call A and B, it really doesn't matter. I'll call this one A and this one B. So if A is 34 degrees and C is 90 degrees, and we've got 180 degrees altogether, then the measure of angle B would be equal to 180 minus 90 minus 34. So I could just subtract the 90 degree angle, subtract the 34 degree angle, and I'm going to get 56. Or another way you could have done it, I just thought of this, since this is a 90 degree angle, the other two angles have to add up to 90 degrees, and I could have just taken 90 degrees minus 34, and that would have given me 56. Actually, I like that better. I'm going to erase and rewrite that. Less work. So 90 degrees here means these two have to add up to 90 degrees. They're going to be complementary. So 90 degrees minus the 34 degrees is going to equal 56 degrees, which is our measurement of angle B. Okay, so we found all the measure angles. Now we need to find the sides. So they've given us one of the sides, B, little b. Well, little b is always the opposite of angle B. So this is little b here. And little a, or side A, is always the opposite of angle A. So when you're drawing these triangles, it helps to draw them out and to label everything. So they've told us that side B is 13. So we found all the angles. Now we need to find all the sides. So we're going to find side A, side B, and side C. Well, we're given side B is 13. We need to then find A and C. So let's look at what we have. We can use either the 34-degree angle or the 56-degree angle for our theta. But if we're going to find A using the 34-degree angle, we're going to use opposite over adjacent. So these are your opposite and adjacent of the 34 degrees. If you wanted to use the 56-degree angle and you wanted to find angle A, or the measurement of side A, you would use, what am I thinking? Tangent. Tangent is opposite over adjacent. So tangent A over tangent of 34 degrees would equal A over 13. If you use the 56-degree angle, that would be, again, opposite over adjacent, which again would be tangent, 56, but it would equal 13 over A rather than A over 13. Okay, it's been a while since I've taught this. All right, so I'm going to use 34 degrees. So tangent 34 degrees is going to equal the opposite, which is A, over the adjacent, which is 13. Now in this problem we will need to use our calculator because 34 is not one of the special angles. To solve for A, I'm going to have to multiply both sides by 13. So the measurement of side A is going to equal 13 times tangent 34 degrees. And that probably shouldn't be capitalized. So now I'm going to get my calculator out and let the calculator do the math. So 13 times tangent 34. I can close parentheses and then hit equals. And we're going to round to the hundredths. The directions tell us to round to the hundredths. That's 2 decimal places. So the 6 is in the hundredths. So we look one more place. The 8 tells us to round that 6 up to a 7. So it's going to be 8.77. So A is going to be approximately, so we're rounding, so we should put the squiggly equals 8.77. And we can now put that over here. All right, now we need to find C. Well, C is the hypotenuse. So if we want to use 34 degrees again, actually we probably shouldn't because angle A or side A was something that we rounded. So instead of using side A, we definitely want to use the one that we were given, the 13 and the C. So you can either say adjacent over hypotenuse. You can use cosine of 34 degrees, which is again adjacent over the hypotenuse, or you could use sine of 56 degrees, which would be the opposite, or 13 over C. So since I used 34 degrees last time, let's use 56 degrees this time, just to have some difference here. So if I use 56, this is opposite over hypotenuse, so which is going to be sine. So sine of 56 degrees is going to equal 13 over C. And again, I want to find C. Well, the problem with that is that C is in the denominator. So like before, in order to get something out of the denominator, we would multiply both sides by the C, which then would give us C times sine 56 degrees equals 13, and then turn around and divide by the sine of 56 degrees. So that we then get C by itself. So once again, we're going to have to use our calculator to figure out what 13 divided by sine of 56 degrees is. So 13 divided by sine 56 degrees equals 15.68. There's a 0 after the 8, so the 8 is going to remain the same. So I get C equals 15.68. And then I'm going to put it over here. So in this box now I have the measures of all three angles and the measures of all three sides. So I have now solved the triangle. That is the end of our notes for section 1. Thank you for joining me.